Welcome! In this series of short videos, we will look at topics for the PowerBasic Windows compiler. Today we will look at going beyond the basic Listbox by using an owner-drawn control. Up until now, all the work we've been doing with the PowerBasic Windows compiler has been using the dynamic dialog tools. Today we're going to go a little further and to stray into the realm of owner-drawn controls. What we have on screen at the moment is a results page. There may well be some applications that you create for your users which are used to perform a number of sequential tasks. As these may take some time to complete, you may want to display for the user a results screen. This results screen will give a list of all the tasks that have been undertaken and whether they have succeeded or have failed. This is the application we're going to create today. What we have on screen is a Listbox, which is going to be used to list the result of each of the tasks. The icon to display whether the task has been successful or not. So let's have a look at the code to see what we have at the moment. At the beginning of our application, there is only one additional include file, that of the date functions, because we want to display the date in our Listbox. We're including 4 bitmaps, a tick and a cross, and a small tick and a cross. We'll cover those in more detail when we get to that point in the code. In our PB main function, we're launching a single dialog. This is a fairly standard dialog, allowing the user to click a button to exit the application. At the top of the dialog, in the frame, is going to be a text box, and this is going to be used to hold a summary of the outcome of our tasks. The Listbox itself is going to have a number of rows, each row detailing the outcome of the running of a task. In our event handler, we're going to set up a timer. We've covered these in previous videos. This particular timer is going to trigger after 2 seconds. Initially, we're going to hide the outcome of the tasks. And after the timer triggers, it will first of all kill off the timer, and then we'll call a function to display our results, passing it 2 parameters, the handle of the dialog and the handle of the Listbox. This function will update the Listbox details. And we're setting to be a maximum number of tasks of 10. So we're going to put 10 rows into this Listbox. And once each task has been updated, we're going to update the overall outcome of our process. So if we test run the application now to see it in its basic format. There's a dialog appearing on the screen, and 2 seconds later it's updated to say success, all tasks have been completed. So this is the starting point of today's video. So what we're going to do first is we're going to amend the properties of our Listbox to make it owner-drawn. So here is the Control Add Listbox command highlighted in the dialog creation. So we're going to add some properties to the end of this command. And this one here is the important one. This is going to be the owner draw setting. This will allow us full control over what appears within this particular Listbox on screen. Normally when you're using dynamic dialog tools, you'll just use the out-of-the-box values, allowing Windows and PowerBasic to do a great deal of the work for you. However, as we're going to be using an owner-drawn control, there's more we have to consider, as we now have full control of what appears inside that control. So let's go into our display result function and start to expand it. So having executed a Listbox reset command to blank out any data in the Listbox, we now want to populate it. So we have a local variable called strText. We're populating that with the word task and the task number. Now we want to simulate whether this particular task has succeeded, or failed, or partially failed. So we're going to create a new function called result, and this will return a number, either a 0, a 1, or a 2. We can do this by using the randomize command, returning a number between 0 and 2. 0 for failure, 1 for success, and 2 for a non-critical failure. So we can test the value of what comes back from this result function. If it returns 0, then we consider that as a task failure. And we're going to set our bitmap ID to be the small cross, the upgrade outcome to be failure, and the individual task result also to be failure. And we'll do the same for the result, which is a success, and also for where the task has been only a partial failure. So now that we've actually set those values, we now have to update our task box. So we're going to create a new routine to add our bitmap and our text to the list box. We're passing a number of parameters to this new subroutine: the dialog handle, the listbox handle, the text, adding on the task result, and our bitmap ID, the one we've designated up here. So let's create this new subroutine. So here is the skeleton of our subroutine taking in the 5 parameters. So we have 2 options here. If we've populated the BMP file variable with the name of a file to load, we can then load the image from that file. However, in this case, we're passing that in as an empty length string. Therefore, we're going to load the bitmap by the handle that we've passed in, rather than loading it from a file. The output from this Windows API call, which loads the image, is to this handle here, and we're going to make use of that handle. We're going to use the control send command to send this string using string pointer to add this to the list box. And then we're going to use the bitmap handle, which we have just obtained using load image, to send also to this list box and to set the item data. This stores the bitmap handle for later processing in our Ownerdrawn event. So now that we have that set up, we now have to go into the event handler of our dialog. Since we have designated the Listbox as being a control which we're using Ownerdraw on, we'll have to specify a custom event to handle the drawing of this particular item. So we're going to create a WM draw item event. This is testing the callback function's W param. If this is equal to the listbox, then we have got the right control. This allows you to do draw item on a number of controls within your dialog should you need to. Now we'll need to set up a number of local variables in this event handler. We'll cover these as we come to them. The first variable we're going to populate is this one. This is a pointer to a draw item structure user-defined type. This user-defined type is going to hold the information for our list box. And this is one of the uses you will find for pointers, in order to structure things so that you can communicate with the Windows API. So we can make the LP_dis variable equal to the callback's L parameter. Now we can test the item ID property. If it has this value here, then the list box is empty and we need do nothing. Otherwise, we know there's at least one item in the list box which we'll need to draw on the box itself. The next variable we're going to populate is this one, the RC variable. It has been set up as another user-defined type, which is the rectangle user-defined type. And we're making equal to the pointer, which is this one here, and the RC item property. Now we have to test to see what action has actually been triggered here. So we're using a select case statement here on the item action property. We're looking for one where it's a draw the entire list box, or where the list box has been selected. So if the item is not selected, we must be drawing the list box. And now we'll start to use a number of Windows API calls to actually fill in details on that part of the screen. The first thing we will do is to clear the background using the fill rectangle API call. And here again is our pointer. And we're passing the handle, the RC user-defined type, and we're using another Windows API call, getSysColorBrush, and it has a parameter of the colour of the window. This way, if the user has radically changed the colour scheme, you can pick up that quite happily using this command. Next, we will use another API call to set the background colour of the text. So now that we're at a point of drawing this list box, Let's try running the code and see what we get. Well, so far nothing's appearing on the screen. So we've obviously got more code to put into place. However, our failure and the subsequent underlying non-critical task reporting is working quite happily. So let's push on with the rest of the code. So as with the code above, we're going to use the same commands again, the fill rectangle and the set background and set text colors. We're also using the RC user-defined type to define the left and right margins. So how do we get the data to appear on our list box? First thing we'll need to do is to get the text which has been added to the list box itself. And we can use a control send command for this. We're sending to the dialog, to the specific list box, and we're giving it a get text command. And we're passing it, again by this pointer, the item ID, the entry on the list box. And we're giving it a var pointer for the text which we set up at the beginning of our function. In here, which is a 300 character ASCII Z type. So we're now going to adjust the text position ever so slightly by incrementing the n top property of the RC user-defined type, the rectangle. We're setting the n left to be our text margin, which is a constant we set up at the beginning of the program. Now we're going to use the draw text command, yet another Windows API to allow us to draw text to a specific control. Again, we're giving it the handle using our pointer. We're giving it the string we just got a moment ago. We're telling it how long that string is. We're passing it the user-defined type, which is the rectangle. And we're specifying a single line, and we're marking it as vertically centered. So we now have enough code within our Ownerdrawn section to actually draw the text on the list box. So let's have a look to see what it looks like. And there is a dialog, and 2 seconds later we get the 10 tasks appearing. So we've done the first part, we've got the text on the list box. But now we have to put the graphics, the bitmaps themselves. So we're going to use another control send command. Again, back to the list box, and we're requesting the item data this time. Using the pointer to our item ID and populating this variable here, the ITD variable. This is going to be our handle. And assuming it returns something other than 0, we can now attempt to draw the current item's bitmap. This of course uses another Windows API call, the drawState call. And again we're passing yet more parameters to it. Again our pointer with the handle to the bitmap which we recovered a moment ago, and we're telling it our margins and where on the screen to actually position it. And with this complete, we can now exit the function. So let's try running that now. And there are our bitmaps. However, vertically, the lines for each of the entries appear a little compressed as it's cutting off a little bit of our bitmap. So we need to set the vertical height of each of the entries in the list box to be larger. So if we go back to where the dialog was created, into our show dialog results function. And in here we're going to use another control send command. We're going to send to the dialog, to the list box, and we're going to use the set item height. And we're going to set that to around 22 pixels, which should be big enough for our bitmaps. If we try running that now, we can see we've now got more space and it looks more presentable on screen. So is there anything more we can actually do to this list box to enhance its look? If we go back to our event handler, and in a section of code which handles drawing the entire list box, we're going to put a bit of conditional coding in here. We're going to set it to highlight alternate rows. So we can test to see which row of the list box we're on by using our pointer again. We're returning the item number and we're doing a mod 2. This will give us the remainder of that value divided by 2. So the result of that calculation is either going to be 0 or non-zero. this allows us to colour alternate lines. So just as we did before, we can use the full rectangle commands again. This time we're changing our colour brush to be the colour of the 3D face. In this case, the default value would be grey. So if we try running that code now, the dialog will appear, and when the results come in, each alternate line is grey in colour. This makes it easier on the eye to see the value of each line. So what we have done today is we have taken a results page using a standard Listbox. We've set that Listbox to be owner-drawn, which gives us complete control about what happens within the Listbox itself. We've used that to display a bitmap as the first entry on each line. The bitmap either being a tick or a cross depending on success or failure. We've also increased the height of each line to make them larger vertically so we can actually have the full bitmap displayed. If you wish to put larger bitmaps in, you can increase this height even further. And we have additionally coloured each alternate line a grey background colour. In order to see what happens if we actually get a success, let's just tweak our results to only show successes. We will mark it between 1 and 2. If we run that now, and there's what you will see as an overall success. You will still get failures, but those will be acceptable failures. So this has been a short introduction to owner-drawn controls. Hopefully you'll find this useful in your code, but that's it for today. Thank you for watching.